All right, so we're now going to start focusing on a more detailed analysis of the Java Streams capabilities. And to do that, we're going to have a simple case study example, which I call the SimpleSearchStream program. And so what we're going to do starting here is give a quick overview of the structure and functionality of this program. And we're going to use this program to show off a bunch of different Java sequential streams capabilities. This program finds words in an input string. So given an input string, it goes and looks for words to find in the input string. And you can get the example here at my GitHub repository at the link at the bottom of the slide. The actual input string is the lyrics to the whimsical Do Re Mi song from the classic 1960s movie, The Sound of Music. And so we're going to have that as the input, and then we're going to look for the words, which are the names of the musical notes, Do, Re, Mi, Fa, Sol, La, Ti, Do, from the song. And this will demonstrate a bunch of Java functional programming features like lambda expressions and method references, as well as some of the Java sequential streams operations, such as the map, filter, and collect operations, which are all examples of aggregate operations. And the output of this program is nicely formatted display of all the places that each of the search words matched at the corresponding indices within the input string. So that's what it looks like if you actually run the program, or something like that. There's also some other kind of interesting results that demonstrate other Java features, such as drop while and take while. And this is going to demonstrate the concept of slicing and dicing. And so you can find where certain words appear. And I'll show you that when we get a little bit further along. So this will print out the results of places where we're looking for things that either match or don't match the words that we're passing in. So let's start by taking a look at the driver program that produces all these results. This is available in this particular file in my GitHub repository. If you get the slides and click on that link, it'll take you to the repository. And this is the main entry point. Obviously, every Java program has a main entry point, just like every C and C++ program has a main entry point. In this particular example, we start out by using a test data factory file that has a method called getInput, and we're going to give it the input file, which will be the Do, Re, Mi lyrics, and we're going to give it a special symbol, and it's going to create an input string that contains the lyrics to the Do, Re, Mi song. And you can take a look at that. It's kind of an interesting implementation. Then we go ahead and get another file that contains the list of words we want to search, which in this case will be the Do, Re, Mi names. We then create an instance of a class called word searcher, and that will go ahead and take the input, which we got from the test data factory file, and make an object that will do word searching. We then go ahead and say, hey, word searcher, please go and find the words to find. That gives back a list of something called search results, and then we go out ahead and print the search results in various different ways. And we'll show some examples of that a little bit later on in this discussion. So that's the end of the overview of the program. It's very simple, as you can see, just really meant to kind of drive the use of all the Java 8 features. This is also an example of how you can combine more classic object-oriented programming with functional programming. So functional programming will be the implementation of methods like getInput and getWordList and find words and so on. And this is just the driver that's doing more classic OO style design and implementation. We're now going to walk through the implementation of some of the methods in the test data factory class that I mentioned earlier, just to show you how you can use Java functional features to integrate with Java I/O streams. So this particular program is used, as we saw earlier, over here in the main program in order to be able to get the input string containing the lyrics to the Do, Re, Mi song, as well as to get the list of words to find. Those are methods in the get word in the test data factory class. So here is get input string. You give it a file name and a splitter. The file name in this case is this, which is the Do, Re, Mi lyrics. If you know The Sound of Music, you've probably heard that before. And over here is the program that actually, or the method that actually parses this thing. So we start by opening that file, the one that's called doremi.tech. And we then turn that into a URI. And then we use a very interesting method called read all bytes. And read all bytes is a method that appears in the files class, which is part of Java I/O streams. And what it does is it goes to this URI, and it reads all the bytes in the file into memory, and it stores it as a string. So we end up with a new string that contains all the contents that were read from that file. And then what we do is we take the regular expression splitter that we were passed, which in this case, if you take a look at main, is the @ symbol. And if you look over here, then it's going to go ahead and read everything from the file, and it'll snarf it all in, and it'll then go ahead and split the whole file into a stream of strings. So we're going to split everything up into a stream of strings, as you can see here. And then we're going to filter out any empty strings. We didn't have any empty strings, but if we had had empty strings, it would have filtered them out. And then we collect the results, which is this stream, into a list of strings. So we end up with a list of strings coming out here. So this collects the results into a list of string objects. And that's what gets returned from this particular method. So that's how we get the input that we're going to be processing. And then the other thing that's interesting here is shown with get word list. And what word list is going to do, or get word list, is going to come over here, and it's going to, again, load everything from the system, from the word list, which is just do, re, mi, fa, sol, la, ti. And it's going to read that in. As you can see, again, we turn this into a stream via the lines factor method. Lines is a method that is part of I/O streams that can convert, in this case, a file into a stream of strings. And then we filter out any empty strings, and then we collect those results into a list of string objects. So that's just kind of showing you, kind of wrapping up the various pieces, showing how the implementation works